Next question is, the angle of elevation of the top of a tower from a point on the ground which is 30 meter away. So let us start building the diagram also. Let us say this is ground. Angle of elevation of top of a tower. Let this be the tower. From a point on the ground which is 30 meter away. Which is 30 meter away from the foot of the tower. Here is the foot of the tower, isn't it? So a point on the ground, this point on the ground makes 30-degree angle of elevation to the top of the tower here. Then we have to find the height of the tower. So let us just denote it by some points A, B, C. So here actually we need to find AB, which is height of the tower. And if we think in terms of perpendicular, base, and hypotenuse, so obviously this will be the base and this will be the perpendicular and this will be the hypotenuse, isn't it? So is there any trigonometrical ratio which involves base, which we already know it's given 30 meter, and then perpendicular, which is basically the height of the tower? So we are talking about P and B. So you may remember that it's tan trigonometrical ratio. So tan 30 is P upon B. So the value of tan 30 is 1 divided by root 3. You can just check some of the earlier videos how we derived this 30 degree, 45 degree, 60 degree and all other kind of significant angles. And P is height of the tower, so that's okay, that is to be found, and B is 30 meter. So by doing some reshuffling we can get this one as the height of the tower, or we can also simplify it like this. So 10 root 3 meter will be height of the tower. Okay, so we have also seen this question. Let us go further and take us this question. Question number 5. A kite is flying at a height of 60 meter above the ground. Okay, so let us assume that this is ground and here is the kite. So it is 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. Let it be the string attached. We will just name it A, B, C. So the string attached to the ground will be represented as AC. The inclination of the string with the ground is 60 degree. So although it do not looks like 60 degree, let us assume it's 60 degree. So the angle of elevation is 60 degree. Find the length of the string. Okay, so we need to find AC in the figure we have made. Assuming there is no slack in the string, basically, practically speaking, there will be some slack due to gravity of the ground, like it will be like this one due to its own weight. But we assume for the sake of simplicity that it is a straight line. So AC is a straight line. Okay, so how to find AC? So here, out of all three things, we know that this is perpendicular and the AC is hypotenuse, and yeah, so and this 60 degree is the base angle. So basically, if we try to just make a relationship between P and H, then we need to use sine, because sine is equal to P divided by H. P is already given 60 meter, and H we need to find out. So sine 60 is root 3 by 2. Its value is root 3 by 2 is equal to 60 divided by H. Or by just some rearrangement, we get this as the length of string. Did you understand how and why I have written this one? So that we can just take out the common factor. So here 40, we get 40 root 3 meter as the length of the string. Let us take up next question. A 1.5 meter tall boy is standing at some distance. Okay, let us start making the figure. Suppose this is 1.5 meter tall boy standing on a ground. At some distance from a 30-meter tall building. Okay, so he is just standing. Suppose this is 30-meter tall building. This is the building which is 30 meter. Angle of elevation from his eyes to the top of the building increases from 30 to 60 degree as he walks towards the building. Okay, so here now it is becoming little bit more complicated, but it's we will see how to solve it. What it says that firstly, when the boy was at some distance, his eyes were making 30-degree angle. with the top of the tower. So angle of elevation is 30 degree. And then he walks towards the building. Suppose he walks till this point. From this point, this was his original location and this is the new location. And again, now he is here. When he is here, he is making angle of elevation of 60 degree. Now find the distance he walked towards the building. Okay, so we need to find the distance. So this looks like a little bit complicated problem, but we will try our best. If you can try, if you want to try by your own, just try to do it by yourself by pausing this video. And then if you want to know the solution or how we can approach this problem, solution of this problem, you can continue watching. First of all, let us be very systematic in our thinking. So our first goal or step was to just clearly mention all the points. So that we can actually visualize the situation very easily. So top of the height of the tower is 30 meter. Height of the boy is 1.5 meter. Firstly, he was making 30-degree angle of elevation towards the top of the tower, but then he walked little bit, df, and now he is making 60 degree. So that is basically the question. Okay, so we have to apply some of our geometry knowledge also here. So let us just join this line, make this line parallel to the ground. So this will also be 1.5 meter, isn't it? And this will also be 1.5 meter because these two lines are parallel. If we call it G, then DG is parallel to CB, isn't it? So GB will also be 1.5. GB will also be 1.5 meter, and that is the height of the boy. Now, what will be AG in that case? AG will nothing but AB, which was height of the tower, minus GB, which is actually height of the boy. So 30 minus 1.5 will be equal to how much? 2.28.5 meter. So this height is not 30 but 28.5 meter. So in triangle AFG, this triangle, we know AG, which is a kind of perpendicular, and then we want to know the this distance. So what is involved? What trigonometrical ratio is involved here? So we are talking about P, and then we are interested in B, or base, perpendicular and base. So perpendicular divided by base is tan 60 degree, which is equal to root 3. So from here we get B is 28.5 divided by root 3 meter, isn't it? And this B is actually FG. This distance, isn't it? Now, but basically what we actually want to know, we want to know what is the distance of DF, because this is the distance which the boy has actually walked, isn't it? This is the distance the boy has walked, and this is what we want to know. Now, as we know this distance FG, we can say that this DF here is DG minus FG. Can you say that? Now it is becoming a little complicated, but it's very easy to visualize here. DF is nothing but DG multiplied by DG minus FG, isn't it? Then we will get this distance. The distance the boy has walked towards the tower. But why we can't find a DF? What is the problem? We know FG, but we don't know DG. So we need to know DG. And for DG, we need to concentrate on triangle ADG. So let us consider a triangle ADG. So in triangle ADG, we know that this angle 30 degree. Sine 30 degree is equal to perpendicular, which is 28.5 divided by DG. So how much we get? Sine 30 is 1 by 2, 28.5 divided by DG, and this gives us value of DG as 2 times 28.5, so 56, 57, 57 meter. So now as we know DG and we know FG, we can say that the distance the boy walked towards the tower is DG minus FG. So DG is 57 meter minus FG. FG is 28.5 divided by root 3. meter. So you can simplify this in many ways, but this will also be the answer. You can either calculate that in decimal, or you can also do various things like taking some common so that it looks little better. 2 minus 1 upon root 3. This will also be the answer. So all these things are could be the answer, and then you can also derive the answer in decimal.